This is geometry transformations, and this is the section on dilations. So a dilation is a special transformation. It is a transformation that may change the size of a figure. It requires a center point and a scale factor. Scale factor, you're going to have to recall to what we learned about scale factor last year. And scale factor just tells us how the two objects are similar. So it could have like a 1 to 2 or a 3 to 4, those types of things. And then we would say the scale factor is, you can say it is 1/4, 1/2, 3/4, that type of thing. So you're going to have to recall how those look. So first off, R is going to be what we indicate our scale factor as. And if the absolute value of R is greater than 1, the dilation is an enlargement. So that means we're getting bigger. If the absolute value of R is in between 0 and 1, it's a reduction. So it gets smaller. And if the absolute value of R is equal to 1, it's a congruence transformation. So it actually does not change size. It just, it could be in the same position or it might be flipped. So the way how we figure out where our new points are is if we have a point, x, y, and that's our pre-image, the dilation centered at the origin with a scale factor of R, then the post-image is just Rx times Ry. So we just have to multiply our points by whatever our dilation was. Once again, that's only if we're centered at the origin though. So we're going to do a couple of examples. We are first going to determine if we have an enlargement or a reduction, and what the scale factor is. So the dashed lines, those are the pre-image, and the solid line is our dilation image or our post-image. So this first example, we're centered here at this point, C. Our pre-image is this dashed triangle. Our post-image is this solid triangle. That is clearly an enlargement because it is definitely, our post-image is definitely larger than our pre-image. And now to determine the scale factor, there are a few different ways in which we can do this. We can find a couple of points with respect to C. So here notice that these two corners are on the same point. So the pre-image would be -1 up 1. That's our pre-image. Our post-image going to that same spot would be -1, 2, 3, up 1, 2, 3. -3 up 3. So our post-image will be -3 up 3. So then we go, okay, well, what did we have to multiply by to get -1 to become -3 and 1 to become 3? Well, we times it by 3. So this has a scale factor of 3 to 1. Okay, or our R value is equal to 3. Now, the other way you could have done this, I'm sorry, our scale factor we should have wrote as 1 to 3 because we always want to put our pre-image first and our post-image second. The other way you could have done this is you could have went from the center point and you could have counted up to this image right here. So we could have just said, all right, that's 1. Then you could have counted up to the post-image, 1, 2, 3. So 1 to 3. Now, counting does work out quite well if you are not interested in figuring out what the R value is. But if you want the R value, you definitely want to take a look at those points. So an enlargement and our scale factor is 1 to 3. So this next dilation, here's our center. Well, what does it look like? This looks like it's the same exact shape, just in a different spot. So this looks like it's a congruence transformation. But here we're going to check. So we're going to pick a point here. So this point would be 2, -1. And you can see that this point that we went to definitely corresponds with this one over here. And that one, so the pre-image was at 2, -1, and the post-image then is at -2, +1. Well, there we had to times it by -1. So your R value is -1, but your scale factor would be 1 to 1 because it didn't end up changing size or shape. All right, so now we'll do a couple of examples where we want to graph our pre-image and our post-image. So we have triangle ABC, which has vertices of A is at 2, 3, B is at 1, -2, and C is at -1, 2. So let's first graph those. So A is at 2, 3, so there's A. B is at 1, -2, so there's B. And C is at -1, 2, so there's C. So there in green is our pre-image. All right, now we want to find the image of the triangle ABC after a dilation centered at the origin with a scale factor of 2. So if we have a scale factor of 2, that's our R value is 2. So we just need to multiply each of these coordinates by 2 because we are centered at the origin. So A prime, our new value, would be 4, 6. B prime, our new point, would be 2, -4. C prime, our post-image point, would be -2, 4. We just took each of those and multiplied by 2. So 2 times 2 is 2, 3 times 2 is 6. 1 times 2 is 2, -2 times 2 is -4. -1 times 2 is -2, 2 times 2 is 4. And we just take these and graph them. So A is at A is at 4, 6. So 1, 2, 3, 4. 2, 3, 4, 5, 6. So there is our post image, A prime. B is at 2, -4. So B prime. And C is at -2, +4. So C prime. And then we would connect those to get our post image of what our dilation looks like. All right, we'll do one more like that. Here, triangle ABC has vertices 2, 2. B is at 1, -2, and C is at -1, 1. So I'll do the pre-image in green again. So there's A at 2, 2, B at 1, -2, and C at -1, 1. This time, we want to find the dilation, which is now centered at 1, 1. So we are no longer centered at the origin. We're centered right here. There's our center. And it's got a scale factor of 3, which means we can't just multiply each of these by 3. Instead, we have to do it looking at the points. So here, from this point, I have to go over 1 and up 1 to get to A. Scale factor of 3, if I went over 1 and up 1, I would now want to go over 3 and up 3, because multiply each of those by 3. So from the center point, I go over 3 and up 3. This is now not my new post image of A. Okay, B. To get to B, I went just down 3. So to get to the new B prime, I'm going to have to go down 9, because 3 times 3 is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then to get to C, I went left 2. Well, so if I just went left 2, I'm now going to have to go left 6, because 2 times 3 is 6. So 1, 2, 3, 4, 5, 6. So here's my post image of C. And now you can take your A, B, and C, connect them to get your dilation. All right, so if you are not centered at the origin, you have to plot your new center on the graph, and you have to count from that new center how to get to each point, and then graph them accordingly. So that is dilations.